All right, so yes, I'm Kevin Peuler, and I will talk to you about the lipid nanoparticles in ELN. So I guess the first question is, why lipid nanoparticles and what makes them an intriguing drug delivery system? So I'll go into the advantages, which I'll start with the targeting capabilities. So surface motifs allow for targeting specific cells. And with this targeting capability, you can reduce off-targeting effects. So there'll be less side effects to your drug and less drug would be needed. Lipid nanoparticles have a great half-life. So oftentimes the nanoparticles will have a PEG surface modification, which will allow for immune cell evasion. They're able to carry multiple types of payload, and this does include mRNA, which often undergoes degradation in the body, but the nanoparticles can protect this cargo from degradation, allowing for a therapeutic that is usually very hard to use. They have improved cell uptake, and with that, you can control when the drug is released. So you can allow the nanoparticle to be uptaken by the cell and then release the cargo once it's in the cell. And finally, there is FDA approval. So the FDA is already approving such drug delivery systems, and you can see that with the COVID-19 vaccines by Moderna and BioNTech, Pfizer. So what would we need to capture for our ELN system to ensure that when you're developing these nanoparticles, you would have everything that you would need that you would normally capture in a notebook? So there are different things to consider that you'd like to have captured. You can have your components of the ELN or components of the LNP, the preparation methods, and additional design factors that you might want to take into consideration. So in general, lipid nanoparticles are composed of a lipid mix, and most commonly now is nucleic acid payload. So the lipid mix can include an ionizable lipid, phospholipid, helper lipid, stabilizer lipid. Several include cholesterol or a modified cholesterol, but doesn't necessarily have to include all those. Lipid nanoparticles are very modular, so they can be mixed, matched, modified. So as you can imagine, you can have the same components, but adjust how the formulation is made, and it'll result in a very different nanoparticle that may have different characteristics that you're looking for. So you could adjust the size, the surface potential, your any motifs on the surface of the nanoparticle, all to try to meet your need and provide a good drug delivery system. So looking at how these nanoparticles are prepared in the lab to help inform the development of ELN experiments. In general, you prepare a lipid mixture in ethanol or a solvent, and then at the same time prepare the nucleic acid in an aqueous buffer, usually at low %, and then rapidly mix the two solutions together, most commonly with a microfluidic device. And if a microfluidic device is used, then the flow rate ratio between the lipid mixture and the aqueous buffer is really important to keep track of. And then after you've made your nanoparticles, you probably want to remove some particles that are not the greatest size. So there's a number of different methods, such as extrusion, for improving your PDI. So additional factors for your LNP design can include the lipid oligonucleotide weight ratio, or mass percent, because this influences the encapsulation efficiency of your lipid nanoparticle. as well as the nitrogen phosphate molar ratio. So keeping the charge balance between your amine on the ionizable lipid and the phosphate group on your oligonucleotide backbone. And the LNPs commonly have a ratio of around 6, but obviously, if you want to adjust that, that's something that you'd, of course, keep track of in your electronic laboratory notebook. So what is Scilligence's approach to the LNP workflow? So being able to design empty and loaded lipid nanoparticles. We have 2 different approaches for the calculations. So, and they vary based on the values that the user would have to enter. Being able to handle 1 or 2 ionizable lipids in the nanoparticle design. Pull component information directly from your registration system. So just like with the ADC, you can register your components, so all of your lipids and your RNA using Helm, and being able to pull that into ELN to design your lipid nanoparticle. And then being able to register your lipid nanoparticle directly from ELN. And that'll be available in 7.3. So to give you a little taste of what the form looks like, I'll walk you through the LNP mole % form. So I won't go into the other form today, but so in general, you'll open form. And then from here, you'll create your component design. So this includes your API, and then you can design your lipid mix. So this could be 4 lipids, like this example, with only 1 ionizable lipid, or it could be 2 ionizable lipids with 8 lipids overall. It's very flexible, so you can design it however you like. Then you'll enter your batch information, and they'll pull in the molecular weights and purity directly from our registration system. And then specify your N/P ratio that you'd like to have in this design, as well as the flow rate ratio. And then specify your mass and volume of your API, followed by the mole % of your lipids. Of course, you can adjust the ordering of those, but you'll end up with your mass, volume, stock concentration, mass %, everything calculated for you so that you're all set to go with your experiment. This example is a loaded nanoparticle. If you're making a non-loaded one, then you would need to know the volume of your aqueous buffer, of which we can capture here instead of directly in this line with the API. So the next step in the process is creating a registration form. So there is a major challenge for this form with how complex the formulation can be for lipid nanoparticles. So the uniqueness check we've worked on is able to handle a wide variety of components with varying mole %, and you can vary the mass %. And of course, if they have different mole %, then it can be a different nanoparticle. Same as mass % with your design. And then we're also capturing a number of different fields that you would like to have with your batch, such as your size, PDI, zeta potential, encapsulation efficiency, as well as what the buffer is composed of, your solvent, and so on and so forth. Can all be captured right there in your form. So you might be wondering when these will be available. Well, the ELN capabilities will be available in 7.2, which is currently slated for July of this year. And the regmol capabilities are slated for 7.3, which will be around November of this year. And with that, I can answer any questions, and thank you.